Good morning, ladies and gentlemen. This is Mr. Smith, and we're going to get started with learning at home. We're just going to jump right into Unit 3. We had one lesson left of Unit 2, but we're not going to worry about that for now. If we return, when we return, we'll worry about it then. So now we're just going to jump into linear graphs and interpreting graphs. So 3.1 is all about interpreting graphs. In our first example, at Canada's Wonderland, there's a Viking Rage. It's a large ship that swings higher and higher back and forth. You may have seen it. It's near the drop zone ride. At its highest position, people on the ride feel as if they will fall out of their seats. Imagine how high above the ground you are as the ride progresses from beginning to end. Which graph below shows the relation between the height above the ground and the time elapsed? So on our x-axis, or our y-axis here, we have our height. So do you think, and then on our x-axis, we have time. So which one of these graphs, 1, 2, or 3, do you think represents the height over time? And I'll let you guys answer a quick poll question on that. The answer I would likely go with is graph 2, because when the ride first starts, it's going to be fairly close to the ground. It's not going to be right on the ground because it needs a little bit of suspension. Otherwise, it'd hit the ground every time it came back down. So that automatically rolls out number 3 because it hits the ground right here. So I would say not graph 3. And when we start off, it has to build up. It swings over time and keeps building it up until it finally reaches its maximum height, and then it'll start to slow down. It doesn't stop immediately. So that's why I think graph 2 over graph 1. Graph 1's a possibility, but it's very unlikely because it hits its max height on the first swing, slows down, and then hits its max height again and again and again repeatedly. So that's very unlikely. Next, we have the drop zone stunt tower. Usually we just call it a drop zone. It's a 23-story free fall ride. People are in an open cockpit seat. They're lifted to the top of the ride where there's a brief stop. Then they're dropped straight down, reaching speeds of 100 kilometers per hour before coming to a complete stop. Imagine how high above the ground you are as the ride progresses from the beginning to the end. Which graph of these 3, graph 1, 2, 3, do you think represents the height over time? So again, in our y-axis here, we have our height, and then in our x-axis here, we have time. So which one, graph 1, 2, or 3? And I'll let you guys answer a poll question on that. The way I would think about this is, well, it's gradually going up to the top of the tower, it stops, and then, well, it looks like it's going down at the exact same speed, so that wouldn't be very thrilling. So I don't think graph 1 would work because it's not really dropping you at a very fast speed. It's lifting you up slowly, stopping, and then bringing you down slowly. So that won't really work. I don't think graph 1 would work. If we look at graph 2, brings you up slowly, stops, and then over time, it drops you straight down. It doesn't slow down at all, so you would just drop and hit the ground, and I think that would be the end of most of the passengers, so I'm thinking graph 2 won't work. If you look at graph 3, though, slowly brings you up, pauses, and then drops you down, but then it slows down as you get closer to the ground so that you don't end up crashing the ride. So that's why I think graph 3 is the correct answer. Ben and Ann decide to canoe from their cottage to the other side of the lake for a picnic lunch. Use the information below to sketch a graph showing their decision from the cottage. To show their distance from the cottage from when they leave until they return. They head out in the morning, paddle leisurely to a small beach for a swim. They continue to their picnic spot for lunch. After lunch, they start back across the lake towards the cottage. Approximately halfway across the lake, it starts to rain, so they paddle quickly home. Okay, so I drew out all of this. I'm just going to label it to say what's and kind of describe what's happening. So they start paddling out leisurely, then they stop somewhere for a swim. So there's number one. They stop, and that's where they're stopping. That's why it's a horizontal line. They're stopping for a swim. Then they continue to their picnic spot, and I'm guessing that they're not going quickly. It doesn't actually say. We're just going to assume they're going about the same speed. And then there's a horizontal line because they stop for their lunch. And then they start returning home here. Likely not paddling very quickly, but then it starts to rain here. And that's why they start paddling very, very quickly. And that's why it gets much steeper, that slope. Okay, we're going to go on to the next example. So hopefully that clarified everything. On the grid below, sketch a graph representing the scenario. The axis must be labeled, but the scale of the axis doesn't. So we're not drawing to scale, we're just drawing a rough idea. Just try to draw the correct shape of the curve. A cannonball is dropped from a cliff and hits the ground 10 seconds later. Sketch a graph of the speed versus time. So I'm going to let you guys try and draw this. I'm going to pause the video for you. And then when we come back, we'll see if we got the same shape. Okay, now we're back. And this is the graph that I came up with. Simply because the cannonball is just going to be dropped from a cliff. So I'm expecting a straight line because it's not going to be stopping anyway down because it's just being basically dropped from a cliff. There's nothing to stop it or slow it down. So at this point up here, that's when it's dropped. So the ball is dropped. And then this point here is 10 seconds later because it hits the ground 10 seconds later. And it just has a constant speed here where it's just falling down the entire time. All right, and that should be enough for you to do your practice for 3.1. All the best. If you have questions, make sure to email me.